So hello guys, so welcome back to our channel. So this is your daily destination of data structures and algorithm. So today is another live that we are going to solve today's problem in the lead code. So grab your notebook and get ready. So we are going to start this. So today's problem is lead code 3296. So the minimum number of seconds to make the mountain height 0. Okay, so this is a medium problem, but the technique is it teaches will be binary search and the answer. So it is one of the most powerful and widely applicable patterns that is in the competitive programming. So let's get on to it. So in this is the problem statement here. So first, let us see the problem overview. So let's imagine a mountain. So the multiple workers are chipping away it simultaneously. So each workers have different base speed. So but here is the twist. So the more a worker chips, the slower each additional unit of height become. So the worker fatigue. So in mathematical form, what is your job is? So we have to find the minimal time of all the workers working together in parallel to reduce the mountain to zero height. So you can assign any mountain of work to any worker, but you must choose optimally. Okay, so this is the classic minimize the maximum problem. So the answer is the time at which the last worker finishes. So we want to minimize that maximum. So on the key insight, so the one makes this solvable is binary search on the answer. So the binary search is not for just arrays, so it can be also search for a possible range. So today you will see exactly how. So let us dive deep onto the problem statement here. So you are given an integer mountain height. So it is denoting the height of the mountain. So the height we need to reduce to 0. So you are also given an integer array, that is work times, that is representing the work time of workers in seconds. Okay. So it is where the workers times is base time, the worker of I, which is in the seconds. So they have said that for worker I, so the I is nothing but each element present in the array. So the worker times plus worker times of I multiplied by 2, like that it will goes on. So to reduce the height of the mountain by 1, it takes these many seconds. So to reduce the height of the mountain by 2, so it takes the current time and the current time multiplied by 2 seconds. So we have to return an integer, that is minimum number of seconds that is required to for the worker to make the height of the mountain to 0. So the worker works simultaneously, so they don't wait for each other. So each worker can independently reduce the height by some amount of x. So the time cost formula for the worker is reducing by x unit. So let me take it as like this. Let me open this notepad. So within this, the time cost for the worker, the current worker, the I worker, is to reduce by x units. So that is I worker and x units. Okay, that is, we can simply say that is the worker of time, that is current time, is multiplied by 1 and it is multiplied by 2 and so on. It goes up to multiplied by x. Okay, so this is the short form they have given. So let me paste here. So it is not being copied. So it is multiplied by 1 and it is multiplied by 2 and so on. It goes until x. So this is the formula they have given. So this is a triangular formula like 1 plus 2 plus 3. As we can see, it is 1 and it is 2 and 3 and so on, it goes up to x. So this formula can be converted into x multiplied by x plus 1 by 2. So the total time, the maximum across the workers, since they work in parallel, so the job finishes when the slowest worker finishes. So we want to minimize this maximum. So first let us see the 3 examples they have given. So first example, that is the mountain height is 4 and the time is 2, 1, 1. So there are 3 workers and the mountain height is 4. So first worker is, the index value is 0, so the worker 0. So it will be reduced by 1. Okay, so the first worker is reduced by 1. So now the cost will be 2 multiplied by 1 multiplied by 1 plus 1 divided by 2. So if you calculate this, it is 2 and 2 multiplied by 2 is 4, 4 by 2 is again 2. So the cost would be 2. So it is 2 seconds. So for the next worker, if we take the formula, so worker 1, so now it is reduced by 2. So now the cost is 1 multiplied by 2 and 2 multiplied by 2 plus 1 by 2. So it will be around 3. So it is 3 seconds. So for the next one, so worker 2, so it is reduced by 1. So the same value like here will be there. So it is this 1 second and the cost would be 1 multiplied by 1 and 1 plus 1 divided by 2. So it is 2, 3 and 1. So the maximum is 3. So 3 would be the output. So as you can see, there are heights for 2 seconds and 1 seconds and 1 seconds. So the first one is, if you implement the problem using the value of x and after calculating it, you will get the value of 3 values. So in these 3 values, you just need to give the maximum as the output. So the total time, the maximum across all workers has to be the output. So the first one is reduced by 1, the next one is reduced by 2 and the next one is reduced by 1. So first it is 4 and 4 will be reduced by 1, it will become 3 and 3 will be reduced by 2, it will become 1 and 1 will be reduced by 1. So finally it will become 0. So this is one of the output. So for the next output, they have given the mountain height is 10 and the worker's time is 3, 2 and 2. So if you calculate it, we can just reduce by 2, 1 times of 2 and 1 times of 3. Again it is 3 and 2. So like that you will get 10. So the maximum would be 12. So the maximum output will be given as 12. So as you can see, it is initially 0 and 0 multiplied by 2 will become 9 they have given. So the worker 1 and worker 1 is multiplied by 2 and worker 1 multiplied by 2 multiplied by 3 will given the value of 12. So if you calculate along with all the values, that time you will get 12. So 9, 12, 12, 12. So the maximum value is 12. So same goes for the third output. So 5 and 1. So initially the first element multiplied by 2 and multiplied by 3 and multiplied by 4 and multiplied by 5 and so on. So until you get the maximum mountain height. So once you get it, the value is 15. So the output is 15. Okay. So the mountain height is reduced by 1 each time. So finally it will get the value. So instead of searching all this, we can just use this formula to find for the each worker, and we can give the maximum number, then the maximum time we have given here. So let us see the constraint. So the mountain height can be 1 to the power of 5, and the worker time length, that is the array length, can be 1 to 10 to the power of 4, and the elements which is present inside the array can be 1 to 10 to the power of 6. So all is within the range of integer, so we can simply use int. So let's see the brute force approach, that like this. So this is directly brute force approach. So why we cannot use brute force approach in this, and why we have to use binary search on this current problem. So the brute force approach, so it will try every possible assignment of the height reductions to the worker to complete. So with this mountain height of 10 to the power of 5, with this constraints, with the value of 10 to the power of 4, so the number of ways to distribute the height is exponential. So there is no way we have to enumerate them. So that's why we have to use our own method. So the main key observation here, so if all the workers can reduce the mountain to 0 with maximum of t seconds, so they can also do it with t plus 1 seconds. So it is yes. So the more time means each worker can do at least as much as they can possibly do. So this means it is nothing but the monatomic function. So there exists is some threshold of the value t to the mountain height, that is 3 multiplied. So this is exactly the pattern the binary search works. So it will search from 1 to t plus 1. So there's for certain range. So for example, so like these numbers, so 12, 34, 35, 67 and 78 and 80, 98. So in this range, if it can do it in 34 seconds, it can also do it in 67 seconds. It can also do it in 98 seconds. So if this is possible, all other right side also possible. So we need to find, if it is no, we just have to move right side. And we can simply find this yes, and we can simply return it. So how much the worker can do in the t second. So we just need to calculate the worker and the x value, and it is multiplied by 1 and it is divided by 2. So the value is, so for finding the quadratic formula, we are just going to do floor division with the square root of the sum of all workers. So if the total mountain height is, if the total height is greater than or equals to the mountain height, we can simply say that the current height can be used to fetch the output. So let's see the algorithm to solve it. So we are going to use binary search here. So using this binary search, we can calculate the output. So here initially the left value is 1. So it is the minimum possible time, and after that the right value. So in this we can say the minimum value of the worker times, and it is multiplied by mountain height So and it is multiplied by mountain height plus 1 and it is divided by 2. Okay. So this here is the worst case formula. So it is single fastest worker does everything. So it can find the most and the maximum value that the worker time can have and it will choose that person. And after that we have to just search for simply do the binary search calculation. So when it reaches the middle value, so and it is greater than that time we can go left. So if the total height is greater than or equal to the mountain height, so the right value is greater time, so we can just move left side until it is fails. So when you reach that, we can simply return the output. So when left value is equals to right value, we have found the minimum feasible time. So we just return the left value. So let us see that how to write this solution here. So first I'll go to the compiler. So this is the long that is the solution they have want. So we can simply use long as the return output. So I'll write the code. So first thing, so they have given all of them in the integer type. So we have to type convert it. So I'm using long type conversion. So there is explicit type conversion. So after that, within it, I want to find the minimum element that is present in this array. So after finding it, I can just simply return it. So for that, I am use inbuilt method to find the minimum element. So minimum. So minimum element present in the array or a vector. So the minimum element of the worker times dot begin to end. So worker times dot end. So I will find the minimum element that is present in the array, and after that we can simply multiply it with the value. So first I will find it. So after finding it, I will just multiply the value. I will multiply the value with the mountain height they have given. So that is here. After multiplying this value, we have to multiply this value with addition of this value with 1. So mountain height plus 1 and it is divided by 2. So this is the right side of it. So after that we can simply write the binary search here. So here we have to check one condition that if it can finish the work or not. So for that I'll write one more condition. So for that I'll write another one function for it. So it is a public method. So I'll write one more private method here. So within it, while left value is less than right value. So the middle value is left plus right minus left divided by 2. As we know, it is nothing but finding the middle value, so it will prevent the overflow. So for that, we are first initially subtracting, after that adding and dividing by 2. So that time it will not overflow. So now we have find the middle value. So here, if it can finish, so if it can finish within it, so we'll write one more method for that. So before that, we can write the code here. So the workers, so the array that we have given, so worker times, and after that the mountain height and the middle value. So if it can finish, so that time the right value is will become middle value. If not, it is else case. If it not finish, the left value will become middle plus 1. So after doing it, we just simply return the left value. So here I'll write one more method. I'll create in a private. So I don't want anyone to access it other than me. So I'm giving it as private. So within this, so it will return the boolean type. So it can finish or not. So can finish. So within that we have given the worker times. So the worker times is nothing but a vector. So vector. So it is an integer data type. Worker times and the mountain height. So after the mountain height, the middle value. So the middle value is long and middle. So within that we have to check if it can finish the value or not. So long. I'll create one variable for storing the total height. So long total height is, I'll initialize with 0. After that I have to add it all the values. So I'm writing worker times in worker times. So W in worker times. So W is a variable which will store every element through every iteration in the worker times array and store it here. So now we can simply check. We have to find the x value. So for finding the x, so here also we have to type converse it. So it will be in integer. So I'll previously do type converse here. So for finding it, there is a formula we have previously discussed that it is negative 1.0. Okay, it is multiplied by the square root value of 1 and it is added to 8 and then added with the value that is t by w. So the mid value is the time, so that is t. So t by w. So we have find the value. So after that we have to divide it with the value 2.0. So for this multiplication purpose, I have given in float value. So after doing it, it will be type convert into long value. So now the total height value is added with the x. So we have to check if the total height is greater than or equals to the mountain height, we have to return this true. So or else we have to return so the total height is greater than or equals to the mountain height or not. Okay. So it is simply return the false. So we don't need to do anything. So this is the method. So in this code, I'll explain one more time. So here it is long. So the return type is long because the answer can be more than the integer that can hold. So that is beyond the 32-bit that integer limit. So anytime we have to compute, so it will be multiplied by the power of 2. So that time this value will be exceed the 32 bits. So that time we have to store it in long here. So the next one is the left range of boundary that is stored in long and I will initialize with 1. So the minimum possible answer is 1 second they have given, that is 1. So that's why I have given it 1. So we never go below the value. So at least some work have to do. So we use long for the left and the right we have to avoid the overflow of the midpoint calculation. So for that we have found the formula. So the worst case is the only one worker, the fastest one, handle the entire mountain. So even if a one person can do that, so that is the minimum element in the array. So the minimum time that person can take to solve it or break down the mountain, and it is multiplied by the mountain height and it is multiplied by plus 1 by 2. So it is nothing but the sum of the mountain height divided by 2. So it is a, so the right bound is faster worker time, that is the height is multiplied by height plus 1 divided by 2. So it is achieved by all the workers to the best worker. So that why we have typecasted it before here. So long. So it will convert it into which can be calculated and it is having higher storage than the integer variable. So next one is the binary search 2. So the standard binary structure we use left plus right minus 2 for finding the middle value here. So here we have given while left is less than right. So why we have given instead of left plus right by 2 we have given left plus right minus left by 2. So it will prevent potential overflow. So when left and right are larger values, so that time it will safer to avoid the overflow. So next one is if it can finish, okay, if the middle second is enough time and it can finish the return true, so we try smaller value, and if it the smaller value is also getting it, so we can just simply store it here, and if not we can just move the left element by 1. So the middle second is not enough, we definitely need more time. So middle plus 1 will be the left value. So when the left value is equals to right, we can converge the minimum feasible time. So let us move on to the can finish. So this is a function we can check that if it can finish within the certain time or not. So for each worker with the base time we compute the maximum height they can reduce in the seconds. So the t seconds is nothing but the middle value. So using the quadratic formula derived earlier, so we cast the mid value divided by the weight to the floating point. So by writing the 8 multiplied by t by w, so this is ensures no integer division caching. So we cast the result to long to get the floor value. So this is used to get the floor value. So we cast the result So the larger whole number, the units this worker can handle. So we add it to the whole total height. So the yearly exit. So if the total height is greater than or equals to the mountain height, we will return true. So if it is not, so that time we can give the key optimization. So once we have already confirmed the height is reduction, so there is no need to check the remaining workers right side it. Okay. So this can save a more time. So when many workers are first. So after that we can return it. If it is greater than the mountain height, it will return true. If not, it will return false. So it will not execute and the left value will be move one by one. So finally when the loop gets outside it, it will return the left value. So let us check it. So the test cases are being passed. So let's dry run. So first, let us see for the first one. So the mountain height. So the mountain height they have given. So the mountain height they have given is 4. So mountain height is 4. So the worker times are 211. So these are the two inputs they will give. So now we will go on to the problem and iterate through this input and get the value. So now first iteration. So I value is 1 like that. So in the first iteration, the middle value is the left value. So that is 1 plus the right value that is 10 minus 1 divided by 2. So it is nothing but 11 by 2. So the 11 by 2 is 5. So 5 is the middle value. So the current middle value is 5. So we have to check it can finish within the 5 seconds. So if it is finished within the 5 seconds, we have to return it. So initially the work is 2 seconds here. So the x value is, we have to find the floor value. So that is nothing but the floor value. So minus 1 and square root of this value. So minus 1 and L multiplied by 5 plus 1. So when you multiply this value, you will get square root of 21. So the square root of 21 and after that it is divided by 2. So if you calculate it, the square root of 21 will be approximately around 4.5. So the 4.5 minus 1 will become 3.5 and if it is divided by 2, it will become 1.7. So the floor value is what? Okay. So after that, for the next x value, the floor value of the value that is minus 1 plus square root of 25 and it is divided by 2. So square root of 25 is 5. So 5 minus 1 is 4. 4 minus 4 divided by 2 is 2. So the output is 2. And for the x value, the next floor value, so minus 1 and the square root of 21 again, and it will be divided by 2. We'll get 1 here. So these are the x values we'll get. So while adding these x values, we will get x value is 1 and 2 and 1. So here we have to check that the total height, so that is nothing but the value they have given us 4. So we have to check if 4 is less than or equals to the current values we have found. So that is 1 and 2 and 3. So in these values, as you can see, the maximum value that we can found here is 3. So in this values, we will get 3 as the maximum value. So that time 3 will be written as the output and 3 will be printed here. So let's submit this solution. So now let's move on to the next problem. So next problem is adding of two numbers in a linked list. So you are given two non-empty linked list that is representing two non-negative integers. So the digits are stored in a reverse order. So as you can see here, 243 and 564. So if you add this 3 and 4, so first we have to add these two values, as they can say it is in the reverse order. So it is 342 and 465. So it is stored in the reverse order. So we have to add in this manner. So 5 plus 2 is 7 and 6 plus 4 is 10. So 0 is here and 1 will be stored as the carry value. So 4 plus 3 is 7. 7 plus 1 is 8. So it is 708. It is nothing but 807. So the output is 708. We have to print. So this is what it should be here. So we have to write a solution for this linked list. So let us see how to solve this problem. So it is LeetCode number 2, add two numbers. So we are just going to add, but the numbers are stored in the linked list. And it is also in the reverse order. So with which the digits scattered across the nodes. And we have to handle the carry in this problem. So let us see the problem here. So let us see the full problem breakdown with examples and 3-node structure and some linked list fundamentals that we have to know. So before we reading the problem, let us see the problem. The main thing that they have given, that is nothing but the structure they have created for the list node. So structure list node, and they have given it is the value, and this star next is nothing but pointing to the next value. And these three are constructors. So based upon the input we have given, it will change according to it. So here the linked list will be visualized in a pointer. So for example, it will be like this. It is a one value and this is another value and this is another value. This value points to the next value and this is point to the next value, and this value points to nothing, that is nothing but null pointer. So let's see it. So let's see the problem. So you are given two non-empty linked list and non-negative integers. So the digits are stored in the reverse order. So each nodes contains a single digit. So you can assume that the two numbers do not contain any leading zeros. So there is no leading zeros except the number 0 itself. Okay. So why they have given in the reverse order? So storing digits in the reverse order means, so the head of the list holds this least significant bit. So there is nothing but the LSD. So the least significant digit. So the ones place. So the next node holds the tens place. So the next node has the 100 space, and so on, it goes on. So this is actually a convenient for the addition. So but we naturally add from the least significant value. So it is the exactly the direction we have to traverse through the list. So let's see the next example. So 0 plus 0 is 0, and here if we add it, we'll get this value. So let us see the algorithm first. So the algorithm, so it is directly mirrors the grade school addition. So we process digit by digit from least to most significant value. So which is nothing but the left to right in the reverse order of the linked list. So first let us see the three situations we have to handle. So if both lists have a node, we have to add the both digit like this, and we have to handle the carry. Okay, if you add this 4 and 6, we will get 10. So 0 here and 1 as the carry have to move here, and only link this list 1 as a node, add the digit plus carry, and only this list 2 has a node, we have to add the digit plus carry. Okay, so in all three cases, if this value is having, we have to add it. If it is, if the only one digit, we doesn't need to add this, we can simply add the carry to it. So in every case, we have to add the carry, but if both this exist, then only we have to add the current value. Okay. So for using this, we are going to use the dummy head node trick. So when building a result list, we need to track the head of the result. So a dummy head is sentinel node. So it will use it to create a new node which is pointing to the head of it. So why without a dummy head we need to special case a code for the very real node. So if the result is empty, so this is the head. So otherwise it have to append. So the dummy head eliminates the special case entirely. So the code becomes uniform for every code. So let us write the code. So we have to return the list node pointer anyway. So we create a dummy. So for that, so list node. So within that we have to give the name and give the value of the pointer. So we create a dummy sentinel node and stack it with the value 0. So it will never appear in the output. So it is purely for the construction 8. So its next pointer starts with the null pointer. So we will chain it with the result node. After that, we will remove this dummy node. So next one, the tail pointer. So for the tail pointer, I'll create one more thing. So list node, and here this pointer. So list node star. So the tail is pointing to the address of the dummy. So the tail always points to the last node in our result. So we start with its pointing to the dummy. So every time we create a new node, we attach it tails to the next one. So then we move the tail to the new node. So this gives us big O of 1 for the adding. So we don't need to iterate through it every time. We using this tail node, we can add the value at the end. So for holding the carry value, I'll create one more variable with the value 0. So the carry for the one position to the next one. So it starts at 0. So before any addition, it is either 0 or 1. So a sum of two digits plus carry at the most value, we have to add it. And one more thing, the main thing, that is iterate through the loops. So while if any list value contains in the first linked list or in the second linked list, or if any carry value is present there, we have to iterate through this loop. So, and I'll declare one variable to store the sum of the value. So, in this sum, so if there are any values in L1, okay, we have to add the L1 value. So, L1 dot value. So, this arrow symbols will get the value and store it here. So, if not, it will add the 0. If there is no value in the L1, it will add 0, or else it will add the value. So, the next one is L2. So, if L2 is present, it will give the L2 value, or else it will give the 0. And after that, we have to add the carry of the previous value. So, initially the carry value is 0 and it will add it. So, the next one is the carry value is the sum of the total sum divided by 10. It will help to carry forward through the next one. And the digit that we have to found it using the modulus step. In digit value is sum divided by 10. So using this modulus operator, we can extract the last digit of the every value. So the next one is we have to create the new node and add it to the next one. So now the tail's next value is the tail next is a new list node, and the value it will store the current digit, and the tail will be moved to the next value. So once it's all done, we have to move the pointer to the list1 node and list2 node. So after this, after we have changing the value of tail node, we have to change the list node. So L1 equals to L1 dot next. So what if this L1 is already having a null pointer? So there is no way to move to the next one. So for that, we have to check it first. So if L1 means it will check if it is present or not, and after that, if it is present, it will change the value. Same goes for the L2. So if L2 is L2 dot next. So it will move and finally it will add the value, and finally we have to return the dummy value that we have given. So we don't need to return the dummy value. So instead of that, we can just return the next value of the dummy. So it is dummy dot next. So we can simply return the value and we can return the final value of it. So just let's run it. So it is dummy dot next. So we have skipped the dummy sentinel and written the first real node. So the head of our result is the linked list. So for some reason, so no nodes were created. So the impossible given the constraints. So both lists are non-empty. So the dummy node next would be null pointer. So but by the problem constraints, this will never happen. So we just return the value. So let's go on to the full dry run. So initially the list 1 value is 2. It is 2 and list 2 value is 5. So I will declare 2 variable. List 1 is 2, list 2 is 5 and the carry is initially 0. So next one is the total sum is we have to add 2 plus y plus carry. So 2 plus 5 plus 0 is 7. The next one is carry. So if you divide this value by 10, you will get nothing, that is but 0 and digit. So the current digit is we have to store in the new linked list, that is we have to extract this single digit. So if you do that, you will get the value of 7 here. So 7 will be there and 0 as the carry currently. So for the next iteration, the value will become 4. The L2 value will become 6. The carry is still 0. So the total sum is 4 plus 6 plus 0. So that is 10. So the carry is, we have to divide this 10 by 10. So we will get carry as the 1. So now the current digit is 0. The last digit, that is 0. So it will move on to the next iteration. So 3 and 4. So 3, 4 and the carry will become 1 here. So now we have to add these things. So 3 plus 4 plus 1. So the total sum will become 8. So the carry is 8 by 10 is 0 and the digit is 8. So 7, 0, 8. So after that the loop will stop. It will not go through the next one. So finally we have calculated this, and if you reverse the 708, you will get the value 807. So let us do the complexity analysis of this problem. So the complexity of this analysis, if you calculate it, so where m and n are the lengths of the, so let us take two variables m and n. So for both linked list, so m is the length of the linked list 1 and n is the length of linked list 2. So the loops run over once per digit position. So as we can say, the maximum length of any one of this linked list is the worst case of this time complexity. So the time complexity is big O of the maximum of L1 dot length, L2 dot. So the maximum length of any two of this value is the time complexity of the linked list. So the next one is space complexity. So same for the space complexity. So what we are doing is we are creating multiple nodes with the maximum number of the length that is present currently in the linked list. So L1 dot length, L2 dot length. So the time complexity is also the maximum, which is the maximum length which linked list contains, and the maximum length which linked list contains for the time and space complexity. So let us see the basic and common mistakes that people would do in this current problem. So as you can see, they would do just list, they will check if the current linked list have the value or this linked list have the value. They will miss to find the carry value. So the number one bug is the loop when both lists are exhausted, so but not checking for the carry value. So if I try to remove this, so this carry check and try to submit it, as you can see, some of the test cases will fail. As you can see, around 150 test cases have been failed because of this single digit missing of the carry value. So make sure that you are giving the checking and giving if there are any carry is being left. And the next one is, instead of using this dummy, so they will do directly in the current head value. So it is one of the biggest bug here. So the first iteration need to be special case logic. So that time we have to give the result as the value. So we have to declare or create one dummy linked list that have to point into the next one. And the next mistake is that people would forget that they have to move the tail pointer or forget to move the linked list pointers. So the dereferencing of the null pointer is one of the undefined behavior. So for that we have to check if the value is present or not. So if not, so that time we have to check that we have to always check for if it is next value is present or there. And one more thing, instead of checking if there any value present in the linked list, people would forget to directly give the value. So first we have to check if there any value present. So if not, add 0, or else you can add the value present in the linked list. And one more thing, that they will modify the value of linked list 1 and linked list 2. So we should advance the both linked list. So but we have to do it in the end of the operation. So if you do this operation in the starting of this loop, so entire problem will be get collapsed, and that time it will not do anything. And most of the people forget to calculate the value of carry. So if the sum is less than 9, it is not a problem. So if it is greater than 9, it will gives the value at least 1. So when sum is greater than or equals to 10, it will give the value 0. So otherwise, which is correct for the carry. So but writing carry is divided by modulus 10 will be mistakes. So you have to calculate every single digit separately and the carry separately. And one more thing, they will forget to return the dummy next value. Instead of, they will return the dummy value. So the dummy node itself has the value 0 and it is a sentinel. So you must return the next value, not the same value. So if you return the dummy, so it will include some leading 0 in your result. So the dummy head pattern requires to return some value. So for example, if I remove and if I run this program, my output will be different. So as you can see, we can't return it. So there is no viable conversation. So we have to return the list node type. Instead of that, we have written some other value. So let us give me dot next. And if I run it, I'll get the value. As you can see, it is being accepted. So today we have solved two problems. So first one is the today's problem, daily problem, and next one is LeetCode 2, the add two numbers. So make sure that use a dummy head for the linked list for every problems, and the binary search on the previous problem LeetCode 3296, and in the linked list problem is LeetCode 2. So both are patterns, so that show up in constantly in competitive programming. So if you like this video, hit this like button and subscribe for the daily problem just like this, and stay right there, and make sure to follow our channel, so that time you can get notified if there are any competitions are there. So that's all for this today's video. See you in the next slide.